Hello everyone, my name is Amparo Lopez and I am full professor at Environmental and Hydraulic Engineering Department at Universitat Politécnica de Valencia. In the learning object of today, we will be speaking about data interaction in environmental modeling. When we finish, we will be able to understand the importance of data in environmental modeling and in which phase of this model data are involved. And we will understand also the concepts of uncertainty and sensitivity analysis to get reliable solutions based on reliable data series. So we will be speaking where do we take the data from, where are them in the modeling, uncertainty and sensitivity analysis, and then concluding. So where are data? Data are everywhere, but we must take this data with some sort of apparatus, with something for observation and keeping the data. We can have remote sensing across Earth observation with big numbers of data for environmental applications, or we can have local measurements taken into SCADAs for time series preparation. In any case, we will need to have reliable data along a time period with a short time of measurement in order to have good series of data. So we will have this data in a time series and we will use it in our process of modeling. And then we will have to use our model without this data to have solutions. So we have data measure which interacts with the model many times, and then we have the model output in order to have solutions to propose for the system. So hydraulic models in their several statement parts interact with data. So let's go to see where in this hydraulic modeling, trying to understand what's happening in real hydraulic systems, we are interacting with data. First, when we define the model, we need data to take boundary conditions in terms of meteorology, covered aspects, soil velocities, hydraulic conditions, geology, or other sort of things, pipes, pressure, temperatures, whatever. So these data are used to determine the number of data we have, the time in which we are considering this data, the reliability, and so to select the model and to define what we are doing. When we have selected the model, then we have to run the model. We have to give solutions for any aspects, and we need to calibrate the model to see that it is happening as data says, and to validate the model. So we need data for calibrations and validations aspects when we run the model until we decide that the model is well calibrated and it can be used for future taking decisions. And when we finish with the model, we have to implement the solutions. We have to post-process them. We have to give solutions to the managers who have asked us for a model and to propose any, again, data new series to be compared with real reality to make our model useful for taking decisions. So we interact with data from the beginning, in the running, and in the final aspects of the hydraulic modeling. But we need to have reliable data. Data has uncertainty in terms of existence of variability inside the data we have. And this uncertainty is transmitted inside the model across uncertainty analysis. We have input distributions with some sort of problem of data, and after modeling we have output simulation that also have to have confidence intervals and non-deterministic solutions to consider that we have some sort of uncertainty in our data. In terms of this data, we should decide which are the more sensitive aspects of data to diminish the uncertainty of the final solution. So we have to determine how this uncertainty of the output is influenced by the uncertainty in the input aspects of the model. So we must take all these variables and decide in which of them we are spending more efforts to calibrate the model across a sensitivity analysis aspect. So we can conclude that environmental models represent real environmental problems across the solving of some equations, but data are interacting with the models in any moment, from the definition to the run and final implementation. It is important to consider uncertainty and sensitivity analysis to be able to have reliable solutions with reliable data coming inside the time, and considering that any problem, any error in the input data will be transmitted to the model with uncertainty and undeliverable at the end solutions of the model. So we should consider some sort of non-deterministic models to take real variability of them inside this process of data-model interaction. I hope this was interesting for you. Thank you very much indeed.